Today, Amida Technology Solutions presents what we feel is a novel use of artificial intelligence, machine learning, and advanced data science to produce a graph-based disability profile to enable expedited and equitable health claims. Amida designs, develops, configures, and operates data management infrastructure for our federal, state, and commercial enterprise clients. Amida was founded by former Veterans Affairs CTO Dr. Peter Levin, who serves as CEO, and VA's first Presidential Innovation Fellow, Matthew McCall. Our president is former Assistant Secretary for Special and Low-Intensity Operations, Michael Lumpkin. Mr. Lumpkin is also a retired naval officer and Navy SEAL. Our chair is Michelle Fournoy, the former Undersecretary for Plans and Policy. In this video, we wish to make the Tradewinds marketplace aware of a graph-based machine learning approach to disability claims adjudication. Graph databases represent data in a way that is more easily searchable. They enable feature extraction for machine learning applications that is difficult or impossible using conventional methods. Our solution is based on 3 competencies and components: our superior knowledge of claims processing generally, and VA claims specifically, our superior knowledge of clinical data management, and our recent innovations in artificial intelligence-driven graph for a Navy project. We understand the information adjudicators look for, know how to collect and reconcile it, and can train automated decision support applications to ensure disability assessments are fair, equitable, and fast. We feel this solution effectively aligns with 2 strategic focus areas: to improve decision-making with advanced data analytics and streamlining business processes. Artificial intelligence-based benefits adjudication has direct implication to DoD in terms of personnel and readiness, the Veterans Benefits Administration, the U.S. Postal Service, the Department of Labor, and the Social Security Administration, all of whom administer disability claims. Amida feels strongly that the government would benefit from a graph-based representation of a computable profile to accelerate the disability claims adjudication process at DoD, VBA, and other agencies. In conventional databases, entity relationships are represented by tables, and their joins are difficult to create and computationally expensive to query. Every record in a relational database management system can be stored as a node in a graph. Table columns become label properties, and forward mapping is easy. The most important thing to know is that nodes, properties, and edges are physically implemented as linked lists and are traversed by pointers. This enables fast processing of complex queries that are infeasible or impossible in relational systems. Consequently, graph databases are excellent at identifying patterns which then reveal gaps in equity, fairness, consistency, and accuracy in claims adjudication. There are well-respected platforms, frameworks, and languages in the market, and Amida has already created a specialized graph-based cybersecurity application for the Navy. The machine learning phase of the project teaches the model what disability decisions were previously made, though we will have to filter legacy data for bias before we use it for training. Once properly curated, assembly of these computable profiles accelerate feature extraction for similarity clusters, decision support, and predictive analysis. Disability attributes fall into 3 broad categories: eligibility, demographic data, and acceptable clinical evidence. The features we map and extract will be captured in that ontology. We will deliver a bespoke application comprised of open source and COTS components that integrates graph with machine learning-based adjudicative decision support. To our knowledge, no such tool exists in the marketplace today. Every foundational component, the models, the query languages, and the physical implementations required for the solution are commercially available and affordable. In that context, the technology readiness level is 7 or more. Even the metadata descriptions of the upstream assets are available. The innovation we propose is an original connection of these components, which to our knowledge has not yet been attempted, but represents low implementation risk. The biggest challenge we anticipate are the access processes of the primary sources. Computable profiles of historical disability claims in a graph format will enable adjudicators to match new claims to precedent and more accurately, more quickly, and more transparently reach a decision based on a well-structured and easy-to-use machine learning-based decision support model. Thank you for your time.